All right, let's jump right in. Today, we're going to tackle one of the absolute biggest questions in artificial intelligence, trust. We're going to explore this really fascinating vision for how to build an AI that's trustworthy from the ground up. I mean, literally from the silicon all the way up to the services it provides. So, let's get into it.
Look, we hear about the incredible power of AI every single day, right? It can write, it can code, it can create amazing art. But all that power really begs a crucial question, one that sits right at the heart of our entire digital future. Can we really, truly trust it? So to answer that, we've got to look at the problems we're actually facing. And it turns out our entire digital world is basically built on a foundation that has two major cracks in it, and they run a lot deeper than you might think.
And here's what those two cracks look like. On the left, you've got the trust gap. I mean, think about it. Our digital systems, even something like a blockchain, they're just software. They don't have a real physical identity, which leaves them wide open to things like supply chain attacks. And then on the right, you see the reasoning gap. This is all about how today's AIs, large language models, actually think. They're basically a black box. They're incredible at guessing the next word in a sentence, but they don't have any real logic or understanding behind it. That's why they can hallucinate and just make stuff up with zero accountability.
Okay, so how in the world do we fix these gaps? Well, you start from the ground up. You fix the trust problem at the most fundamental level you can, the hardware itself. This is all about forging what we're going to call a sovereign body.
And the core idea here is something called hardware sovereignty. It's actually a pretty simple but incredibly powerful principle. For digital trust to mean anything, it has to be anchored to something real, something physical, a unique identity that's just impossible to fake or copy.
So how do you create this physical anchor? Well, what's so cool is that the solution is actually found in imperfection. You see, when any silicon chip is made, there are these tiny random variations at a microscopic level. This technology takes those tiny flaws and uses them to create what's called a physically unclonable function, or a PUF. Basically, it gives every single chip its own unique digital fingerprint. It's like a birthmark that's physically impossible to copy. All of a sudden, your security isn't just software anymore, it's literally baked into the silicon.
Okay, so a physical fingerprint is a brilliant start for proving a device is what it says it is. But what happens once it's already up and running? What's stopping an attack that happens in the blink of an eye?
Well, this is where a particularly nasty kind of hack comes into play. It's called a time of check to time of use attack, or TOC2. It's the classic bait and switch. So first, your system checks a file and says, yep, this is safe. But in the tiny, tiny fraction of a second between that check and when the system actually uses the file, an attacker swaps it with something malicious. The system then runs the bad code, totally blind to the fact that it's been tricked.
And here's the ingenious solution. This special hardware chip has a dedicated security partition built right in. You can think of it like a biological reflex. It is constantly monitoring the code as it runs in real time, and it can instantly catch one of those malicious swaps the second it happens. This gives you a layer of security that software alone, which is vulnerable to these timing attacks, just can't compete with.
And get this hardware-first approach isn't just about making things more secure. It's also wildly efficient. In high-performance computing, this kind of architecture can cut the energy needed for things like checkpointing and restarting after a failure by more than 80%. That is a massive, massive efficiency gain.
All right, so we've established a secure physical body for our AI. That solves the trust gap. But what about the mind? Now it's time to tackle that second huge problem, the reasoning gap, and figure out how we move from a mysterious black box to a transparent glass box.
Like we touched on before, today's LLMs are basically probability engines. They're trained on unimaginable amounts of data to get really, really good at guessing what word comes next. But they can't tell you why they made a choice. There's no concept of logic or truth, which is why they can fail so badly in new situations and are just way too risky for anything mission critical.
So the huge shift we need is from the black box to the glass box. And as you can see here, this is a move away from just probabilistic guessing and toward logic you can actually derive and verify. We're trading this opaque, confusing reasoning for AI that's genuinely explainable. And at the end of the day, this isn't just some nice feature, it's about replacing an unacceptable risk of failure with essential accountability.
And the solution here is a system called NARS, which stands for Non-Axiomatic Reasoning System. Unlike an LLM, NARS is designed from the start to be a glass box. It doesn't just spit out an answer, it shows you its work. It derives a result and explains the logical steps it took based on the evidence it had. That is the foundation of accountability.
This slide shows another huge difference in how these systems learn and grow. A standard LLM gets trained on a gigantic data set, and then its knowledge is pretty much frozen in time. If you want it to learn something new, you have to go through this massive, expensive retraining process. NARS, on the other hand, is built to learn and adapt constantly, in real time. It's designed to reason when it doesn't have all the answers, which makes it perfect for the messy, ever-changing real world.
Okay, so we have the sovereign body giving us a physical root of trust, and we have the trusted mind giving us explainable reasoning. So what's the next logical step? Well, you bring them together in what's called the unified AI architecture.
In this quote right here, it just says it all. You simply cannot have a truly trusted mind, an AI you can actually rely on, if it's running on a body, on hardware that can be compromised. The two are completely inseparable.
And this diagram shows the really elegant way it all works together. So let's walk through it. Check out the center. NARS isn't trying to do everything by itself. Instead, it acts like the boss, the executive function of the whole system. It's the core reasoning engine. And then it directs and uses different specialized LLMs as its tools. As you can see, it can call on one LLM for language stuff, another for generating code, and a third for creative tasks. It's a system where logic is in charge of language, and the whole thing is running on that secure, sovereign hardware foundation we talked about.
So, what does this all add up to? When you combine a trusted body with a reasoning mind, what new things become possible? Well, this is where we move beyond today's pretty simple smart contracts and into the dawn of truly intelligent services. Services that are actually aware of their environment and can react to it.
And the real-world impact here is just profound. We're talking about autonomous agents that can manage incredibly complex systems. Imagine an agent that can dynamically optimize a global supply chain on the fly, or a DeFi agent that manages a hedge fund using actual risk-aware reasoning, or even a governance agent that can run a whole decentralized organization with decisions that are completely transparent and audible.
But the ultimate vision, the end game, is even bigger. This diagram shows what's called service sentience. Now hold on, we're not talking about consciousness or robots becoming self-aware here. We're talking about creating a network that can reason about its own state, its own resources, and what its users actually need. You can see on the left that trusted hardware feeding information into that complex cognitive layer on the right. It's like a living system where physical trust and explainable AI are totally fused.
It all comes down to this simple equation. The physical, unforgeable trust you get from hardware sovereignty, plus the explainable, adaptive reasoning of NARS, that equals the future of decentralized intelligence.
Which leaves us with one last, pretty profound question to chew on. We're not just talking about making our computers a little faster or our software a little smarter. We are talking about building a digital world that can actually reason, adapt, and be trusted. So, what happens when our digital world can truly think for itself?